Hello again, welcome back. Sorry for the long delay between videos. I originally set out to try and make one video a month. That didn't quite work out for the first few videos. It was about like one every 6 weeks, and then there's a huge gap in between after my last video. So sorry about that, but one of the reasons is that I have had NICE allowance, which I was getting income from the government to help me build my business, and that was only for 9 months and it ended in February. So after February I had to go all hands on deck, or by both hands, to earn income to support myself. So I didn't have as much free time to work on many things, unfortunately. But I finally slowly put this video together, and the topic of this video is the Raspberry Pi Pico. When it came out, I think it was in February or March this year, I thought that would be a great little topic to cover, as it was something fairly new. I thought maybe I could make a video about it shortly after it came out, but it's been a few months now. But so yeah, in this video, it covers the Raspberry Pi Pico, just MicroPython, not the C side of things just yet. Didn't have time to cover that, but it's still a little demo. The demo consists of flashing a RGB LED and displaying some text on a screen. So the little demo project I made was controlling the LED color using just some buttons, and then displaying the LED value on the LCD screen. So first you set the colors individually, and then you press a button and it displays the resulting color on the LED. It's a very basic demo. So it's my first time using MicroPython for a serious project. I've used CircuitPython in the past, and that was pretty good. And then coming to MicroPython was a bit different, because I find it doesn't have quite as good library support as CircuitPython. From what I've been googling, CircuitPython is made by Adafruit people, and they also sell products or components, and they make libraries for their components. So they make lots of libraries for their CircuitPython project. So I find a lot more components are supported with CircuitPython than MicroPython, but theoretically MicroPython can also be used just as well as CircuitPython, and I think MicroPython has some other features that CircuitPython doesn't, but I won't go into that into this video. I'll show you the demo of the project, operating it, and a code explanation, sort of looking at how the code works. Here's the circuit, using the Raspberry Pi Pico, some buttons and a potentiometer. It's a pretty simple circuit, no fancy electronics, or mostly direct connections. So the program consists of going through 3 different modes, and you can switch between the modes using the button. In the first mode you set the value of each individual color. So we've got green at the moment, so you can turn that one down about that much. Red, so you can turn that one up a little bit. And then blue, turn that one up really low. So now that all the colours are set, save that in memory, press the next button, and there's the resulting color that comes right. So there's the green, red and blue components generating that color. It's sort of like a weird color, orangey thing. And the final mode is just a color cycle, and I'm going to all different colors just to show that it works. And that's my little Raspberry Pi Pico demo written in MicroPython. This is the code that runs on the Raspberry Pi Pico. It is MicroPython code, so it imports all of the libraries needed at the start there. The LCD library, which I found on GitHub, the fairly simple one, sets up the pins using the machine library and the potentiometer, which is an analog to digital converter. Here you can see some assembly, which is a little code snippet I found on the net for controlling the RGB LED. Don't totally understand what it does, but it works, so that's nice. Uses a state machine, which I believe is a powerful feature of the Raspberry Pi Pico specifically. This video won't cover that feature, but maybe in a future video, maybe when I cover C programming, and I might include the state machine functionality. So yeah, that shows, that's the pixel, the WS2182 RGB LED functionality. Just set up some definitions for colors for the LEDs. It's the LCD, and that's just a demo loop there as it starts up. And here is the main loop that runs the in the main program that runs continuously. So you can see it switches between different modes, interact mode. So if it's the mode that's set the color, then it reads the different colors from potentiometer. So it reads the unsigned int 16-bit integer, and then converts that to a sensible value to 0 to 255. It's a small delay, otherwise I can't remember why I added that, but anyway. And then when it's in the setting color mode and button 2 is pressed, then it switches between the colors. So we go red, green, blue, so when you press the button it switches between those colors. And then down the bottom here, when you press button 1, it switches between modes, so from set, then it goes into mode show. So you can see here in show, it just sets the color, very simple. And then you press button 1 again, it goes into the cycle mode, where it just has a demo color cycle. Yeah, that's about it. I just used some sort of Python's version of enums, which it doesn't really have. A dictionary to define modes, for readability of code, because I like having readable code. Yeah, the code is on my website, so or it'll be on GitHub, so you can have a look at that for more
details, so you can try and make something like this yourself. Yeah, that's it.
Thanks for watching. My experience with MicroPython it's been a mixed one. Like I said, not as good as CircuitPython in terms of library support, but it works, and in some cases it's nicer than Arduino, in that you just it's fast iteration. You save and run, whereas Arduino is save, compile, upload, run, which is a slower iterative process for some things. So that's a rather strong advantage of MicroPython. And for those who are very familiar with Python, it's nice too. Still, my preference is CircuitPython, and you can actually get CircuitPython on the Raspberry Pi Pico. If you look out there, Adafruit have released builds for the Raspberry Pi Pico. So if that's your preference, go use that. I just use MicroPython in this example because that was mostly what was available at the time, and it's kind of like the default language for it. I guess the real advantage of these Raspberry Pi Picos is that they're extremely cheap, a couple of dollars each, which is a lot cheaper than Arduino's even, and they run MicroPython, which is a pretty resource intensive interpreter for microcontrollers. Like, it doesn't run on little AVR chips, but it does run on ARM based processors, and this is an ARM based processor, Cortex M0 I believe, and it's pretty amazing what they can cram into that chip for the price. I think the Raspberry Pi Foundation must have cut some corners here and there to get these chips out at such a low price to hobbyists. So it may very well be a tool that I use in some of my projects due to its affordability. It might just end up in projects just because of how cheap they are. Yeah, and there are some more advanced topics on the Pico, like there is the C programming language, which is a bit difficult to get working on Windows, my current desktop platform, which has some quirks using DOS prompt and things like that, but technically possible. And then there's CircuitPython as well, but also it's got this interesting feature called a state machine, which I haven't looked too much into, but apparently it's a rather powerful feature of it that can, when utilized effectively, can gain you a lot of performance out of the chip. So maybe in future I'll go in more depth in some of those advanced features. It may have been a long time since my last video, but hopefully I'm aiming that my next video it will be a lot less time, because I've got the projects ready to be demonstrated. The main project being the internet radio alarm clock. Some people who watch this channel may know about my alarm clock that I've been working on for quite a while, and it's finally basically done. And I'm ready to demonstrate it and show how it works and how it functions and how it's all put together. I think it's a project that might interest people. Basically it's an alarm clock that wakes you up in the morning with internet radio streams, which I built from scratch using a Raspberry Pi and an Arduino, so stay tuned for that one. And also it just so happened that my 32-bit, which is a little handheld game console, arrived in the mail recently, and I'm pretty keen to play around with that, and I might do a little demo of that for a YouTube video just to give it a bit of exposure and show it off. And back to regular scheduling after those special videos. Have some more projects in the pipeline. I've got a big list of projects I want to make and put on YouTube, including a LED matrix clock, not an alarm clock, just a regular clock, that I can hang up in my room, to show me the time. So using a readily available LED matrix, and a ESP32 internet radio, which isn't an alarm clock, just a plain old radio player that'll be fairly basic and no screen or anything, just a simple ability to play radio stations. So stay tuned, got more coming eventually. May not be once a month anymore, but when I have time. So yeah, some of you I might see at some point, some of you I might see in the next video. Catch you later.